Prerna Chikersal, a fourth-year PhD student at Carnegie Mellon University. The title of the paper I'm presenting is Detecting Depression and Predicting Its Onset Using Longitudinal Symptoms Captured by Passive Sensing, a machine learning approach with robust feature selection. This work was done in collaboration with my advisors, Aninde and Goel, and the other researchers displayed on this slide. Depression is a huge problem today, especially for college students. More than 3 in 10 college students have difficulty functioning due to depression. Depression is also the leading cause of suicide. Fortunately, current treatments for depression are effective and are known to reduce the risk of suicide. But students with depression face many barriers to seeking treatment, the most common barrier being the belief that stress is a normal part of student life. These students are often unaware that they have depression, and so they do not seek treatment, which is why detecting and monitoring depression is necessary. Currently, detecting and monitoring depression in a large cohort can only be done using periodic psychometric tests. However, such tests, when administered frequently, reduce compliance. Hence, there is a need for us to develop more efficient tools to detect and monitor depression. For this purpose, in this project, we collected data from sensors embedded in students' smartphones and fitness trackers in order to capture their behaviors and depressive symptoms. This information was then used to detect depression. Specifically, we worked on detecting 2 outcomes: post-semester depression, which we were able to detect with an accuracy of 85.7%, and change in depression, which we were able to detect with an accuracy of 85.4%. We also predicted post-semester depression several weeks in advance, and we were able to achieve an accuracy of over 80%, 11 to 15 weeks before the end of the semester. Now I'm going to give you an overview of our methodology. This flowchart describes our entire system. First, we carry out data collection. From each student, we collected data from 4 smartphone sensors and 2 Fitbit sensors over a period of 1 semester, which is 16 weeks. The smartphone sensors gave us scanned Bluetooth addresses, call logs, location coordinates, and screen status, while the Fitbit sensors gave us sleep and steps. We collected this data from 138 first-year college students. We also administered a well-validated questionnaire at the beginning and at the end of the study to get pre-semester and post-semester depression severity scores. We mapped these severity scores to 4 depression severity levels of no or minimal, mild, moderate, and severe. We binarized the severity levels to get 2 outcomes: post-semester depression, which is a binary outcome where 0 means that the person has no depressive symptoms and 1 means that the person has mild, moderate, or severe depressive symptoms. And change in depression, where 0 means that the severity level remains the same and 1 means that the severity level worsens. We took the data from all the 6 sensors and extracted these 7 sets of features. Then we trained a model for each feature set and combined the prediction of all 7 one feature set models to get the final prediction. Now let's move on to the results. For detecting post-semester depression, the majority class baseline gave us an accuracy of 59.4%. Using all 7 feature sets, we got an accuracy of 82.3%. The best sensor combination containing Bluetooth calls, phone usage, and steps gave us an accuracy of 85.7%. The best one feature set model is the phone usage model, which gave us an accuracy of 70.3%. That said, as you can see, all one feature set models are quite close in performance. This graph shows the accuracy obtained for predicting post-semester depression at the end of each week of the semester. For example, we find that at the end of week 5, that is 11 weeks before the end of the semester, we were able to detect post-semester depression with an accuracy of 81.3%. For the results for change in depression and other results, please refer to the paper. Now let's talk about the implications of our work. Our work has significant implications for the detection of health outcomes using longitudinal behavioral data and limited ground truth. For example, our prediction models can be used to carry out preemptive interventions in future studies. One way to do this would be to have counselors from the campus counseling center reach out to students whose predicted risk for depression is high and offer them assistance. Thank you. Please refer to my website for the slides and transcripts of this presentation.